Welcome and thanks for joining us. My guest today is Chris Mellis. He's the Vice President of Product Management for T-Mobile. Chris, good to have you with us.
Hey, Tom. Thanks for having me. A pleasure to be here.
And we're going to talk about 5G, which I think for many people is sort of a concept. They see the magenta maps of T-Mobile of where 5G is, but not sure everyone exactly understands what it is, what the status of it is now. So let's start at the 50,000 foot level. What is 5G status right now and deployment and capability?
Sure. 5G is the newest, latest technology that we have in the cellular industry. And to your point, a lot of people don't really understand it. Is it just one better than 4G? That's really not the case. 5G was one of the first times that the technology groups got together to create a new way of thinking about how we run wireless networks. All of the things that we wanted to go do in terms of massive amounts of IoT devices, near wireline broadband speeds, ultra low latency. All of those things were designed into 5G to really start to move away from what we traditionally think of as a slow wireless network that only does phone calls to a pure broadband wireless play that allows people to do as many things as they can possibly dream of. Right now, the state of the industry is very interesting. T-Mobile has a huge lead in terms of our 5G build. We're the only carrier in the United States with a 5G standalone core. And that allows us to do really amazing things and really bring the true benefits of 5G forward. Ultra low latencies, things like network slicing, and a lot of the things and promise that people have read about 5G, we're now doing ready, and we're here doing it today.
Right, and when you mention network slicing and also the accommodation of the growing deployment of Internet of Things devices, this is not just a consumer app type of benefit, but sounds like industrial and large organizations can really see some benefit from this.
Absolutely. 5G was really built with a lot of industry and commercial uses and applications in mind. A lot of customers don't need some of these ultra low latency or super high throughput applications. You don't really need that for your day-to-day use as a consumer. But in businesses, manufacturing, defense, operations of airports, retail, these are industries that are using large amounts of data and need to move them around quickly, easily, and most importantly, securely. 5G really helps enable that in a way that's never been done before on a wireless network.
Now, the consumer thinks of 5G as something that's a service on their smartphone and that you get via your subscription, say, to your T-Mobile account. But is this also something that an organization can deploy that technology locally?
Absolutely. There's a few different methods of doing that. One of them that we've developed is what we call our 5G Advanced Network Solutions capability. This is a custom-built, specific type of coverage and performance that we bring into various different industries to really solve their problems of Wi-Fi is a great technology. We've all used it for a long time, but it's reaching its limitations. It can't handle as many devices. There's lots of interference that happens. And we all have experienced that where we go to a place, we get on the Wi-Fi, it looks like it's really strong, but we can't use our devices. Cellular technology takes all of that away from us. It's just as good as wireline connectivity in a building, but without having all the wires. So now you can think about things being moved around easily in manufacturing facilities, no longer having to be really planned out. You can move things, battery operated devices that can still take advantage of 5G. Everything from small little sensors to wireless routers to phones to modules that are attached now to things like AGVs, drones, and all kinds of autonomous vehicles. So it's a really broadening technology that's going to open up a lot of capabilities for people that they haven't really been able to do before.
And there's a fundamental difference, though, in usage, and that is if you are a smartphone plan holder, and everybody is, including everybody in government, because that's the way the world works nowadays. Where you are is you access the local 5G, and it doesn't matter which your carrier is, but it's there and out there. In some of these custom-built types of installations that you've described, you may want that to be limited and for security purposes, and just because you didn't build it for people driving by. So tell us about the ways and mechanisms by which that can be turned into not necessarily a VPN, but something that is for that campus only, or a certain defined set of users.
Right. It's a great point to bring up. A lot of customers that we work with have different needs. Some of them want fully privatized networks, and we can do that in various ways. Devices that only work on that, making sure the security is high, and we only allow on devices that we know should be allowed on. On top of that, we have a capability with our T-SIM Secure product with no applications on the phone. We can take and segment devices, secure their traffic, and in a way, like you said, create a virtual private network throughout our entire nationwide 5G network. And some customers also go in the other way. They want a little bit for their own private usage, but they also want to have visitors coming in. If you think about some areas like warehousing, lots of different shipping companies are showing up to that warehousing. Lots of different maintenance people may be coming in. Your HVAC people may not be somebody you own. So in those scenarios, we can create both a public and private side of that network at any way that the customer wants. If they would like only very little bit of that capability to go to their public customers, we can do that, as well as we can do a lot of it and keep very small pieces of the private network available for them for their critical use cases. And we see everything in between. So when people are building out a cellular network today, they're really having to think about what do you do from what you want to accomplish with your organization, but also how do you work and interact with people. As you said, people are coming in from all over the place with different phones and different capabilities. So bringing in this purpose-built coverage is really advantageous for just about any type of enterprise.
Yes, because early in the Wi-Fi days and early even in the exterior cellular days, the notion of some kind of a national broadband outdoor network was talked about. And we thought it would even supersede terrestrial radio. That never really developed so far. It sounds like this has maybe the technical foundations for that idea of long-distance exterior broadband for communications purposes.
Yes, when we looked at 5G in particular, how we've built it at T-Mobile, we took an approach of what we like to call the layer cake. So we have some assets in our spectrum portfolio that go really far to give broad coverage that has really never been seen before in the United States in terms of both people covered as well as land covered. And then we move up in the spectrum frequencies to ones that don't go as far, but they have a lot more capacity, all the way up to our millimeter wave spectrum, which doesn't go very far, but has tremendous throughput capabilities. And by us blending those three capabilities together with things like 5G ANS, we are able to provide experiences in a local fashion that are exemplary and mirror anything that we've seen, even with fiber connections, all the way to the most rural parts of the country. And then when you layer in on what we're now doing with SpaceX and bringing satellite capabilities into those phones, there's going to be really nowhere in the United States that you will not be able to connect wirelessly to our network, which is super advantageous for things in a lot of industries. There's a lot of folks who don't stay in one spot. Logistics, trucking, a lot of our government customers, they're moving all around, and we want to make sure they're connected at all times wherever they go.
Yeah, and you make a really good point, which we should explore for a moment, and that is the convergence of satellite with 5G terrestrial, because until now, for the dead zones where your phone comes up SOS, people have had to have a sat phone, and those are expensive and not really that practical mass technology. Sounds like there's a little bit of convergence going on here.
There is. It's something that the industry has been looking at for a long time. In fact, I was once at a startup looking at this, maybe an idea before its time. But now that the technologies have advanced far enough and the satellite coverage that we have has grown exponentially, especially on the commercial side, it's really given us a capability to do some amazing things. And as technology in the handsets have advanced, as you said, it used to be what we've all seen in movies and TVs, giant phones, maybe tied to a suitcase with a big dish. The technology has allowed us now to get that down into the regular iPhones and Samsung and Android devices that everyone's carrying today.
And you mentioned something called network slicing. And that, what is that, and how does that benefit the organization?
Network slicing is an amazing technology that only 5G can do, and only when you have a 5G standalone core. It's why you don't hear as much about it everywhere in the U.S. right now. You really only hear it from T-Mobile because we're the only ones capable to do it today. What slicing allows us to do is create virtual networks inside of our physical network. Previously, if you wanted to have a different experience than everybody else, you had to go a very expensive route. You had to go build your own private network. You had to ask for it to be configured a certain way to meet the business needs that you have. Say, I want a very, very low latency, but I don't really need a lot of bandwidth because I'm doing sensor updates and I need those quickly. What slicing allows us to do is, in our normal commercial network, we can create virtual networks that meet the exact needs of the customers and what they're doing. We've done 2 slices so far commercially that we've announced. One of them I mentioned earlier, our T-SIM Secure, which does a routing of traffic securely back into other threat advancement capabilities, checking all of that traffic and then routing it to appropriate where it needs to go. And one that we're really most proud of is the one we just announced last month, which is our T-Priority slice, which is the first network slice built for the first responder communities in this country, giving them a very unique experience on our network that is tailor-made for them so they can do the things they need to do when they need to do them.
Right, and this is something that can be stood up or stood down as needed. I mean, it's not a permanent thing.
Yes, we call it a slice, which most people think of as a slice of cake or pie or pizza, which doesn't change, as we all know. Our slices can be dynamic. And in the case of T-Priority, that slice is set up to expand and take up as much capacity as needed in the event that there's a critical need for first responders in that area. During most of the time, they're just getting a better experience. Their traffic is prioritized. They can get on the network easier. They can even move people off the network if they need to in the time of an extreme emergency case. But as more and more first responders show up, this slice will dynamically and automatically expand its capabilities to take more and more first responders, giving them that same experience in that location. So it's an amazing technology that allows us to really service very specific use cases anywhere in the network at any time and expand to meet the demands and needs as they need to happen in very specific geographic locations.
But at some point, you don't want to use up all of the absolute capacity with slices. So is there enough headroom, or do slices maybe scale down when they're not being invoked?
Absolutely. They scale down to the minimum that they need to provide the resources to whoever needs them. So at some points in our network, you might not see any slices invoked if there's no one who's needing to use them at that time. At other times, we expand them up to as much as we need to in the network, especially on T-Priority. We all think about it, and when a first responder shows up, we really want them to be able to do their job versus maybe someone streaming some Netflix videos. Of course, we make sure that people can get in touch with their loved ones and contact them to let them know they're safe and do all of those things. We would never, cut off all the communications, but we really want to prioritize what our first responder community can do, because when they're coming on a job, we need them to be able to do that job. And so we give them as much of the capability that they need to do what they need to do when they show up.
All right, on that note, we're going to take a short break. My guest today is Chris Mellis. He is the Vice President of Product Management for T-Mobile for Business. I'm Federal Drive host Tom Temin. This is Federal Insights, sponsored by T-Mobile here on Federal News Network. Welcome back to Federal Insights, sponsored by T-Mobile here on Federal News Network. My guest today is Chris Mellis. He's the Vice President of Product Management for T-Mobile for Business. I'm Federal Drive host Tom Temin. And in 5G, in some ways, it's analogous to the IP version 6. When that first got deployed, it had a lot of capabilities. One of them was greater security. And talk about the security and cybersecurity capabilities under 5G that may not be available under 4G, LTE and prior generations.
Absolutely. Earlier generations of cellular technology weren't really built with inherent security in mind. Of course, the standards bodies and all of the ecosystem around it tried to make it as secure as possible, but you were originally dealing with analog signals and a lot of different technologies. So there was a lot of layering of other things that had to happen on it. You mentioned earlier VPNs, right? That was a way to come out and provide security over an unsecure network. And they do really well, except they have a lot of problems with overhead, with crashing, with sometimes not being able to connect. So as 5G was being created, the whole design was thought through with security in mind. Everything through the phone to the towers, everything through the core networks, and even down into the manufacturing, knowing and understanding where chips are being built, how are they going through, what is the supply chain capabilities that are being done to track that. So it is a very, very robustly secure system. And at T-Mobile, we've gone even a step further with our capabilities in T-SIM Secure, where we can take all of the traffic off of a phone only based on the SIM card that's in the phone, secure it, move it, treat it, protect it, and move it to where a customer needs it, as well as the steps that we've taken overall in our network. We have a very, very robust security program. Our cyber program is very robust. Sometimes to the detriment of some of our internal users who maybe can't do all the things they like to go do, but we do that to make sure that we have the most secure network possible, not only from the base technologies, but also how we run and operate it, and also the other services that we provide for customers, like T-SIM Secure and some of our other capabilities.
And does this involve encryption?
It does. Almost everything in a 5G network is fully encrypted. It's a pretty impressive when you think about the computing power that's needed to compute the encryption keys and do all that as fast as the way our phones are working. And on top of that, T-Mobile also uses a very stringent policy around how we treat our data, more stringent than any other carrier. We call it a USGCI compliance. So all of our data, all of our systems are completely audited at all times before we even build them. Who has access? What's the data? Where is the data accessed? And it often causes us to go through and create some new capabilities to make sure that the customer's data is super secure and treated and that there's no risk to them.
And what about government usage data and numbers and traffic? Because government on the same network has different concerns and requirements and, frankly, privileges than, say, private communications. And what are the differences there, and what can you tell government about that?
Yeah, absolutely. We treat all of our traffic, with the utmost levels of security to start with. But when we think about when we work with our government customers and our government partners, we really try to think through, again, how are they using their data, where are they using it, and how do we make sure it's most secure? All of our systems go through, as I mentioned earlier, a very, very intensive auditing process, not just from a design perspective and a process perspective, but also a technical perspective, access to those systems, who can get to them. And then we also look to make sure that when we work with our government customers, most of the time we never let that traffic actually hit anything public. We take the traffic in on our network, we make sure it's secure all the way through our core, and then we actually do secure communications back into government data centers and facilities to deliver that traffic directly to the government. So as often as possible, we like to do that with our government customers and our federal customers. It just gives us all a better sense of security that we don't have things going over some of the older technologies that were used. We've also done some things where we've asked our government customers to maybe look at their improving their security, moving their standards up to things that are today more aligned with what we do with 5G. And people have been very receptive to that. So not only are we working to protect our data, we're working really hard to help others learn to protect their data as well.
And what about the infrastructure for wireless? Because even wireless systems eventually touch the ground and touch a wire, and there is a whole infrastructure of towers and devices that download and network devices. What about the security of those, and what about the supply chain and provenance of those? It's a big concern for government.
Yes, it is. It's why we look at our supply chain very critically. It's just as critically as we look at the design of our network and the software that we run. We have a very secure supply chain capability where we track and we know where every box that comes into our network, where it's come from, what's its domain of origin and provenance, how is it being used, who can access it. Our physical security is also very important. It's very difficult to get access to many of our areas that we need to do it through multiple layers of physical security. And then on top of that, there's tons of encryption and other security. In fact, most of the time it's very difficult for us to even look at data inside of our network because it's encrypted. So we can know who it is because we have to know who our customers are to service them, but we don't know what they're sending and what they're doing on the network. So it's a multi-layered approach to our security capabilities, starting all the way with how we track supply chain, to our construction, to our physical security of those elements, and then as well, on top of that, multiple layers of security inherent in 5G and the radio networks, and then on top of that, other security measures we do in terms of things like secure SASE and other capabilities that we make sure there's multiple layers of security to get through before anyone could get to that data.
And I wanted to get back to the question of that idea of a campus 5G network, a private 5G network that a military installation may want, or a warehouse, or the organic industrial base type of plant, for example, just to think of a couple. What is required in terms of hardware infrastructure? You know, if you want water on your base, you have to build a water tower. That's a really big, imposing, ugly-looking thing. What's required for local 5G private installation?
That's a great question, and one that most people don't really truly understand when they talk to us, just like we said about earlier with 5G. Private networks have gotten quite a bit of popularity in terms of the requests we get from customers because they hear a lot about it. But we take a multi-level approach. Our first is very customer-centric and focused. We don't come in and just give you a private network. We first talk about what the customer wants to do with their network, what kind of data they're going to be transmitting, what kind of performance do they need from that network, and then we derive the design for them that most fits their needs in the most practical and economic way. That can range anywhere, Tom, from building an entire data center practically on site. So a truly full private network where there's no risk of that data ever leaving that area and compound. Data sovereignty is very important and performance is very important, as well as disaster recovery. In the rare event that maybe a fiber line gets cut and redundancy backups are taken out, that's the type of solution we put in for things that are critical infrastructure in airports, things that we just can't ever have go down. For things that are just as important but maybe can take a little downtime or don't need as much of that capability to be on site, we have a capability we call our hybrid 5G ANS solution. And that's really bringing the minimal amount of equipment on, which is really small, tiny radios, a little bit of network switching equipment, and then we leverage the security and capabilities of our macro network as much as possible to help the customers get to a lower cost point of entry, but still achieve amazing results of what they want to do. So in some instances, we see both getting deployed. So it's really a mix and match of various different technologies. It's not a one size fits all from how T-Mobile for Business thinks of it.
And some of this outdoor gear in the 5G area is small, like the size of a loaf of bread or half a loaf of bread type of thing on the side of a building.
Yes, absolutely. We can show you some radios and other capabilities that you wouldn't even recognize. Most of us are probably used to driving around and seeing big towers with these giant antennas on top of them. The technology has now gotten down to things that are as small as a hockey puck. To can provide that capability. So not intrusive, not the big ugly water tower anymore, but we have lots of different ways to solve lots of different problems in our arsenal, and we bring them to bear depending on what the customer needs are and the performance that we're trying to give them.
And the average federal installation or agency now is not just communicating within its own data center, but cloud adoption has gotten to be pretty ubiquitous. Talk about how 5G plays in the cloud world, where there's all of these communications channels going every which way, really.
Yeah, the cloud world and what the hyperscalers moved was actually advantageous for us, for those building 5G networks. It had already come over a lot of the objections of my data is not being here, it's not on site, and what we in our careers probably remember in mainframes and big data centers, and moving that to the cloud really helped us come and say, well, why would you run your own infrastructure as well? You're not running any of your computing infrastructure and data center. Why wouldn't you're leaving that to experts? People who are doing it at scales that you can't get to. Why wouldn't you do the same thing with your wireless network? So that was one amazing entry point for us to come and say that. Also, 5G is so great and built for that. Large, huge amounts of data, very low latency to move things around. It's a perfect match to go put with cloud providers and what they do. And then to really make sure we followed that, we built our network to have the lowest latency possible to those cloud providers. So we have built a many number of egress points out of our network, keeping you to as close as the cloud providers that you need to get to, and as close to our network capabilities as you need to really keep that latency as low as possible when we're using cloud capabilities. It's pretty amazing what we've been able to do with just a little radio puck online, and everything else is now running up in the cloud.
All right, well, we could go on, but we are out of time. Some really great insights into this whole brave new world of 5G. I want to thank you for being with us. Chris Mellis is the Vice President of Product Management for T-Mobile for Business. I'm Federal Drive host Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search T-Mobile.